Alright guys, this is concept 2 in our unit 1. Please check your Canvas and verify that you have watched the last 20 minutes of the first video in concept 1. Remember to just fast forward to the 35-minute mark, and once you have that done, you can start this one. So concept 2, shifting, reflecting, and stretching graphs of functions part 2 plus piecewise functions, continues off where we leave off from concept 1. Okay, in the space below, summarize what would be done to which coordinates x or y if a graph were shifted, reflected, or stretched in any direction. What this is asking us to do is to summarize the table we completed a couple pages back, I believe. Okay, so for this first one, okay, what they want is just like a summary. Okay, so if you shift up, or if you shift it up, okay, that means your y is added to. Okay, if you shift down, or if you shift it down, your y is subtracted from. Okay, if you shift left, or if you shifted left, your x is subtracted from. If you shifted right, x is added to. Okay. The other one, or at least the next one, would be reflection over x-axis. So if you reflect it over x-axis, what would change, right? If you're reflecting over to the bottom quadrant, your y changes sign. If you reflect it over the y-axis, okay, your x changes sign. Oops, x changes sign. And then finally you have the vertical stretches or compressions. And this means your y is multiplied by a, let me see, we could say by a stretching or compressing factor. Okay, so we just summarized that table that was in the previous one. Why did we do it again? Okay, you have to be able to just be able to write in mathematics. Remember, recall that I said that you guys will be practicing some free response. Okay, so you have to be able to go back and forth, whether it's table data, just written data, graph, equations, and so on. Okay, for this first one, it says the table below shows ordered pairs on the graph of a function f of x that consists of line segments connecting the points in the table. Use the table below to create a table of values for each function below that is a transformation of the graph of f of x. Okay, and here's the transformation. Yeah, g of x is equal to negative f of x plus 2. Okay, so knowing or taking what we know now, okay, about transformations, we have a negative in the front of f of x, so I know the first thing I'm going to be doing is I'm going to reflect over the x axis. Okay, and then the other one, I have f of x plus 2 outside of f of x, right? So I'm going to shift up 2 units. Okay, so you got your x's, you got f of x, your y's in other words, okay? So this first column here takes the ordered pairs. The first point would be, or when x is -3, your y is 5. Okay, this would be a point on the graph of f of x. So you have -3, comma 5, -1, comma 1, 1, comma -4, this one, right? It's this one here. 3, comma 1, 5, comma 2. So what would be, or it says state the shifts and or reflections that f of x undergoes to obtain the graph of g of x. We already did that here. Stating what changes are made to which coordinates of f of x to obtain the coordinates of point for g of x. So what we're going to do is apply the transformations to the table data. Okay, or are my points here. So what would be the x coordinates on g of x? Notice that my transformations are only really affecting my y values. I reflect over the x axis, but when I reflect over the x axis, the sign on my y changes. Okay, when I shift up to units, I'm going to be adding only to the y. Okay, so then the x coordinate of g of x, those don't change. Okay, so -3, -1, +1, 3, and 5. Okay, again, those were the x coordinates here. The y coordinate of g of x, okay, that's these guys here. I reflect over the x-axis, so they become negative, okay, and then I add 2. So the first one, here's 5, so I have -5, it's reflected over the x-axis, and I shift up to units, so I add 2, and this would be -3. Okay, and that would be the same case for the others here. I'm going to try to do this faster so that this video doesn't get too long. So -1 plus 2, that's 1. Then I have +4 plus 2, I get 6. -1 plus 2, I get 1. And then -2 plus 2, I get 0. The last column here would be, okay, now list the ordered pairs of the points on g of x. Here's the x coordinate, here's your new y coordinate. So this now would be -3, comma -3, -1, comma 1, 1, comma 6, 3, comma 1, and 5, comma 0. That's it. Okay, you just found this info on the transformations of f of x to get to g of x. So next page, we have more examples, similar case. Okay, so I'm going to go faster on these. Feel free to pause the video if you need to. Again, this is so that the video doesn't get too long. Okay, so for this one, I have same case, right? State the shifts or reflections, the transformations, in other words, done on f of x to get h of x, and then same case. Okay, what are these points here of f of x equivalent to on g of x? Okay, considering the transformations. So I have, take this 3 here, I have a vertical stretch by a factor of 3. I have f of x plus 2 within f of x, right, and it's positive, so this would be a shift left 2 units. Okay, and then finally I have -3 here outside, right, so this is a shift down 3 units. So you can look at it as, maybe we could just generalize this here, and I think let me see, we didn't do it here, so let's just backtrack for a quick second here. Okay, one easy way to be able to get your what goes on this column to get this column, right, the y values, the y coordinates, you can also write out how those coordinates would look. We didn't touch the x here, so x comma, and then you would have, right, we reflect over the x-axis, so you have -y, then you add 2. This would be like the general formula per se. Okay, so that's the previous one. For this one here, okay, I have, are my x's being affected? Yes. Okay, I am shifting to the left 2 units, so I am subtracting 2 from all my x's. Okay, I have a vertical stretch of 3, so that is multiplying my y value by 3, but then I'm also shifting down 3 units, so I take away 3. So this would be the general formula for the transformation on these points. Okay, the x coordinates on h of x, I'm subtracting 2 from each x, so negative 3 minus 2, I get negative 5, negative 1 minus 2, I get negative 3. Here I got 1 minus 2, negative 1, 3, minus 2, I get positive 1, 5 minus 2, I get 3. The y coordinates on h of x, I multiply each one by 3, so 3 times 5, and then I subtract 3, right? Yeah, so 15 minus 3, and I get 12. Then I have 3 times 1 minus 3, I get 0. Then I have 3 times negative 4 minus 3, I get negative 15. Then this one's 3 times 1 again, minus 3, I get 0 again. And then 3 times 2, 3 times 2 minus 3, I get 3. Okay, now you put these together and you got your new ordered pairs. So negative 5 comma 12, negative 3 comma 0, negative 1 comma negative 15, 1 comma 0, and 3 comma 3. Okay, that's it. Next one. Number 3, I have the negative in the front here, so it's a reflection, or you reflect over x-axis. I have a minus 2 f of x minus 2, so this is a shift right 2 units. Then I have plus 2 out here, so it's a shift up 2 units. Okay, so let's write what would be that general formula, right? So I'm shifting right 2 units towards the positive side, so I add 2 to my axis, and then I'm reflecting over the x-axis, so that makes my y negative, but then I shift up 2 units, so I add 2. And there's your general formula. Same thing here now. So I add 2 to my axis, so negative 3 plus 2, I get negative 1. Negative 1 plus 2, I get positive 1. 1 plus 2, I get 3. 3 plus 2, I get 5. And 5 plus 2, I get 7. For the y's, take each one. Negative 5 plus 2, I get negative 3. Then it's 1, negative 1 plus 2, I get positive 1. This is negative 4, so it becomes positive 4 plus 2, I get 6. Then this is negative 1 plus 2, I get positive 1. And negative 2 plus 2, I get 0. So then now my new ordered pairs, take each one, and I have negative 1 comma negative 3. Oops. 1 comma 1, 3 comma 6, 5 comma 1, and 7 comma 0. Okay. Alright. Next one here, I have a negative x here. Okay, it's a reflection over y-axis. Oops, y-axis. Now, recall from our previous lesson, okay, when you have a negative, when you reflect over the y-axis, pull out what would be the negative 1 so that you can get what the expression looks like inside. So let me do this. Let me see. I'll do this over here to the side. So I have negative x plus 3 right? That's what's right here. This is equivalent to negative 1 times, or just negative, times x minus 3. Okay? The negative will still reflect the y over the y-axis. Okay, we'll still make this reflect, but this is really x minus 3. So the transformation, because it's minus 3, it's shift right 3 units. Okay, and then finally, this last one here, it's shift down 2 units. Okay, so, and then the general formula therefore would be, if you reflect over the y-axis, remember, just like how your y's become negative if you reflect over the x-axis, if you reflect over the y-axis, now your x's will become negative. So you have negative x, and then you shift to the right 2 units towards the positive side, so you add 3, comma, and then you just shift down, so y minus 2. So I get, it's negative 3, so negative x, it becomes positive 3 plus 3, you get 6. Positive 1 plus 3, you're going to get 4. Negative 1 plus 3, you get 2. Negative 3 plus 3, you're going to get 0. Negative 5 plus 3, you get negative 2. For the y's, it's just subtracting 2 from each one, so 5 minus 2 is 3. 1 minus 2 is negative 1. Negative 4 minus 2, you get negative 6. 1 minus 2, you're going to get negative 1. And then 2 minus 2, you get 0. Take the order of pairs now. 6 comma 3, 4 comma negative 1, 2 comma negative 6, 0 comma negative 1, negative 2 comma 0. Okay, that's it for this. We got one more. Okay, it's concept 2 at piecewise functions. Okay, piecewise functions. Remember these guys. We didn't like them, right? But hopefully they're easier this time around now that we're familiar with more complex functions. So here's like a shortcut way to think of how to graph these, right? Remember that I would tell you graph the entire function and then erase what you don't need. You can go ahead and take that approach. Okay, but knowing what we know about transformations, okay, we can use that to make things a lot faster. Okay, this right here, okay, it's a quadratic, it's a parabola. Okay, we know that the parent function of a parabola starts at the origin and it opens, right, going upwards from the center, from the origin. Okay, this is in vertex form, okay, which means I can go ahead and, you know, apply a transformation to what would be the vertex here at the origin. Okay, this is x minus 2, so it's a shift towards the right 2 and then down 3. So if my vertex was here, I shift to the right 2 and then down 3. So here's where my new vertex is. Okay, now I know my parabola is going to open this way. Okay, what you can take next is evaluate these endpoints, okay, so that you know exactly how much of the graph you need. So towards the left side, okay, at negative 1 is right here. Let's see where, what's my y, okay, when I have negative 1. So if I plug in negative 1 here, okay, negative 1 minus 2, you get negative 3. Negative 3 squared is positive 9. Take away 3, you get 6. Notice that this graph is possible when it's greater than negative 1, not equal to, okay? So you have a open circle. We said it was positive 6, so there's an open circle there at positive 6, okay, when x is negative 1. Similarly, take now the 4. Plug in 4 minus 2, you're going to get 2. 2 squared is 4, subtract 3, you get 1. Okay, so when x is 4, you get 1. But notice that x is less than or equal to 4. So this is a closed circle. Okay? And that's it. Now you know your parabola exists within that interval there. Okay? Now let's take the bottom one. This is linear. It's 2 over 3x plus 2, right, in slope-intercept form. This is true for all x is greater than 4. So this linear, this line, okay, would be going this way. So from here, we can go ahead and evaluate and see where this line starts. Okay, so if I plug in 4 here, I have 2/3, right? So 4 times 2, you get 8 over 3. 8 over 3 is go ahead and use your calculators for this one yet. Let me see. I'm getting 2.66, and then I add 2, and I get 4.66. So I go here. So I have 4.66. I notice that x is greater than 4, not equal to, so it's an open circle. Okay. I'm approximately there. Now my slope is 2/3, so go up 2 units and then to the right 3. So about there. Okay. That's all you really need. Now you can sketch the rest. Whoops. The rest of this line. Don't forget to write your arrows, okay, if it keeps going forever. And that's it. We just graphed that first piecewise function. For number 2, it looks like it gets more complicated, but no, it's still the same approach. Okay, recall that the absolute value function, okay, I think we did, yeah, we go over these in a few pages back. Okay, these are the ones that, right, they're super pointy. Okay, disregard the fact that my parabola here looks pointy. Anyway, so these guys start again at the origin, and then they go like that. Okay, apply the transformation right here. X plus 2. You're going to shift to the left 2 and then up 1. So shift left 2 and up 1. So my new vertex, my absolute value of the first one is here. Okay. Notice that this is true for all x's less than -1. So there is no parameter going this way. Okay, so I can go ahead and start or sketch the rest of what my absolute value is there. However, as I move towards the right side, this is where it starts to change. Okay, so for there, let's evaluate at -1. Okay, so let's see how far it goes. So when I plug in -1 here, -1 plus 2, I get +1. Absolute value of +1 is 1. 1 plus 2, I get 2. So at x is equal to -1, I have 2. Notice that it's less than, so it's a open circle. Okay, so it just goes like that. Okay, y is equal to 3. Recall that those are just horizontal lines. Okay, and that's true exactly where x is equal to -1. So at -1, I have 3, what would be a line, but it's only true at x is equal to -1. Okay, so I have just a point there. Okay, now the last one, same thing. So let's see where I start from -1 for this line here. When I plug in -1 here, okay, -1/2 times -1, you get +1/2 plus 5, that would be 5.5. So at -1, I'm at 5.5. And notice that it's also an open circle. So I am here. Okay, my slope is -1/2. Okay, so go down 1 to the right 2. Okay, plot that point there, and then that's all you need. Okay, that's it. There's your second piecewise. Let's go to the third one. You can pause here if you feel like you've gotten it. That's fine. Okay, but watch the rest of the videos if you feel like you still need more support. All right. for the third one, I have some radicals now, and don't let these scare you because it's still the same thing. Okay, I have negative x. Okay, negative x would be a reflection over the y-axis. I know this normally goes this way, okay, but instead I'm going to have it go this way now. And then up 3, so it's a shift up 3. I know they usually start here, so instead I'm going to start here. Now notice that this is true from x is negative 4 all the way to 0. So I'm going to graph this radical from negative 4 to 0, only in this interval. Okay, so let's evaluate that 0. By plugging 0, square root of 0 is 0 plus 3. And again, this makes sense because I'm just shifting up 3 from the origin. Okay, and it's an open circle. For this one's going to be a closed circle. Let's evaluate at negative 4. By plugging negative 4 here, it's already minus, becomes positive 4, becomes 2, 2 plus 3 is 5. So when x is negative 4, I get 5 here. And notice that it's a closed circle. Sorry, there you go. So that's it. Okay, that's what that part of the radical will look like. For the next one, I have another horizontal line, but this is true only at x is equal to 0, which means it's just going to be a dot, a point. Okay, so at 2, at x is equal to 0, I have a dot here. Okay, and then the next one, I have the square root. Remember, it goes like this from the origin, right? But I'm going to shift up 3. So if I shift up 3, I'm right here again, right at this open circle, and it is open here as well. And then I know from here, it's just going to go, yes, it's going to go just like this. Okay? And that's it. That's number 3. Finally, number 4. This one, oops, here we go. This one looks a bit complicated. Let's see. I have a reflection over the x-axis, right, and it helps to rewrite what's inside here whenever you reflect over the x-axis, so you can see what the horizontal shift is. So I just took what's inside the radical here, and again, that's equivalent to x plus 2. If you distribute the negative in, you get what's inside. Okay, so this is actually x plus 2, which is a shift towards the left. Okay, and then up 2. So, and also there's a reflection over the y-axis. So instead of going this way, I go this way. Whoops, I go this way. So from the origin, I shift to the left 2, and then I go up 2. So right here. This is where my parabola will, my radical will start. Okay, this is x is less than negative 2, so it's true for everything going this way. And notice that it's an open circle. I'm at negative 2 here, so this is actually, let me fix this, an open circle. Okay, this is open. And then again, remember to trust the process. Okay, all the points will transfer over. Okay, what would be right here 1 comma 1, or instead negative 1 comma 1, it's going to be up here. Okay, and then it'll be something like this. Yeah. Okay. Next one is linear. Let's evaluate at negative 2. So at negative 2, when I plug it in here, I get positive 4. Subtract 2, I get positive 2. And that starts here, and it's an open circle. Okay. Then when I evaluate at 1, when I plug in 1 here, negative 2 minus 2, you get negative 4. So when x is 1 here, I'm at negative 4 here. And that is also an open circle. Oops. Here we go, right here. Okay. And I can connect these because again, it's linear. It's a line. Okay. And then finally, the last one, I have a a reflection over the x-axis. So instead of going from the origin like this, I'm going to be going like this. Okay, you can probably already guess where it's going to start from. And then I have a shift to the right, down 4. So if I were to start from the origin, I move to the right 1, then I go down 4, and then look at that, I'm here at the open circle, and it makes sense because that's where it starts from. Okay, and then that's it, right? You have a reflection over the x-axis. So instead of going this way, okay, you know it's going to be going this way. And all the points receive the same transformation. So what was 1, 1 is reflected. So you're really here. Okay, you reflect over the x-axis. You go to the right 1, and then down 4, which is right here. Okay, and then it would look something like this. And that's it. That's the 4th piecewise function. Okay, now you guys have what you need to be able to complete the first homework assignment.